Now let's use a Crank Nicolson scheme to derive a discretization of the diffusion PDE on a lattice in space-time. Right, and the Crank Nicolson scheme, the key idea is to look at quantities of the differential equation at this point, and this is the point at xj time TL plus a half, halfway between time L and time L plus 1. Okay, now, at that point, the time derivative can be approximated by the difference in the grid values of u at time L plus 1 minus time L. And this is both at position xj. So it is approximately 1 over tau u L plus 1j minus u L j. This double space derivative at this point, well, we can't get it directly because we need to difference along here. But what we can do, we can take differences along here and differences along there and average the two. So, two x derivatives at j time L plus a half is going to be the average, a half of the estimate of the space derivative there and the estimate up there. Right, so at time L, the second derivative can be given by our well-known formula, namely u j minus 1L minus 2ujL plus uj plus 1L divided by h squared. And then the estimate of the second derivative at time L plus 1 is the same formula with L plus 1 instead of L. So 2uj L plus 1 plus uj plus 1 L plus 1 over h squared. Right? And the average of those two estimates the second derivative. Okay. Put that into the differential equation, and that's evaluating the PDE, or approximating the PDE at that point. So the left-hand side is 1 over tau uj L plus 1 minus ujL, and the right-hand side is this, with a common factor of 1 over h squared and that factor of k. So we go k over 2h squared uj minus 1l minus 2ujl, so uj plus 1l plus uj plus 1l plus 1 minus 2ujl plus 1 plus uj plus 1l plus 1. Okay, now multiply by tau, and what we have over here, k tau over s h squared, is just the parameter s. So let's use that. And also multiply by this 2. Both sides. And so the left-hand side has 2. Alright, now the next step is, because we march forward in time, so we magically know what the solution is at time L, and we're trying to find the solution at time L plus 1. So we put all the time L plus 1 things that we don't know on the left, and all the time L things on the right. So, where's the time L plus 1? Well, we have S u j minus 1 L plus 1. Move it to the left, and it's minus S. Then we have uj L plus 1. There's minus 2s of them on the right, and there's also 2 on the left. So that turns into 2 into 1 plus s, uj L plus 1. We also have uj plus 1, L plus 1 times s. Move that to the left, and it becomes minus s, uj plus 1, L plus 1. That should be a minus. That's the left-hand side. and the right hand side is all the time L things. So the first one is S times U J minus 1L. Then we've got S times UJL, but there's minus 2S UJL. There's also 2UJL on the left. Take that on to the right, it becomes plus 2UJL minus this 2S, means it's 2 into 1 minus S UJL. And then the last term is this UJ plus 1L times S is S UJ plus 1L. And that is the Crank-Nicolson discretization of the partial differential equation. And it's that we need to analyse and implement.